find the power series representation for the following function ln absolute 2 plus 3x, and we need to find the interval of convergence as well. And all the time in this section we are using the fact that the power series for 1 over 1 minus x, okay, or 1 minus anything, is equal to sum n from 0 through infinity, that whatever we have x to the n, and the absolute value of x less than 1. Okay, now we need to relate natural log of this to 1 over 1 minus x, and we know that antiderivative of 1 over 1 plus x is natural log of 1 plus x, but we have to get 2 plus 3x, natural log of 2 plus 3x. So if we integrate 1 over, let me put 2 plus 3x, okay, 2 plus 3x with respect to x, that's gonna be, now we need to do u substitution. This is our u, so 1 over u, so that will be natural log of 2 plus 3x, and from chain rule, I mean from u substitution, we need to divide by this 3. Okay, if we were differentiating, we would multiply by 3. In this case we divide by 3, so plus some constant c. So to find the power series of natural log of 2x plus 3, we need to find the power series for this. Okay, find the power series for this and integrate. Done. By the way, 1 over 2 plus 3x is in the form of 1 over 1 minus x. Okay, we can change this into 1 over 1 minus x and we are good. So we start with the power series of 1 over 2 plus 3x in this way. Note that 1 over 2 plus 3x is same as 1 over, because we need 1 but we have 2, so we can factor 2 out from these two terms. So 1 plus, there is no 2 but we factor 2 anyway, so we need to divide by 2, 3x over 2. Okay, you can check if you distribute 2 inside, 2 times 1 2 plus 2 times 3x over 2, 2 to cancel 3x, so this is good. Now we can rewrite this as 1/2 times 1 over 1 plus 3x over 2. Now I want to write in this way, 1 over 1 minus x. So 1 plus 3x over 2 is same as 1 minus negative 3x over 2. Okay, now this looks like 1 over 1 minus x. This 1/2, and using this rule, okay, we get sum n from 0 through infinity of whatever we have here, that's negative 3x over 2 raised to n. Okay, and this is valid for absolute value of negative 3x over 2 less than 1. And we can take this 2 inside. Let's simplify this. 1/2 is still outside, n from 0 through infinity, there is a negative, so we can always take negative 1 to the n to the front, and this is producing positive negative sign, and we have 3 over 2n, which is 3n over 2n and xn. Okay, and if we simplify, absolute value of negative number is same as absolute value of positive number, and we can multiply by 2, so multiply by 2 and divide by 3, this becomes absolute x less than 2/3. Okay, this power series is valid when x is in between negative 2/3 and positive 2/3. Okay, so we found the power series for 1 over 2 plus 3x. Now we need to connect this to natural log of 2 plus 3x, and we know that antiderivative of 1 over 2 plus 3x is equal to natural log of 2 plus 3x divided by 3 plus some constant. So this power series is in fact for 1 over 2 plus 3x, Now we want to integrate both sides with respect to x. Okay, so integrate with respect to x. Yeah, we could have taken 2 inside, then 2 and 2 raised to n. When we multiply, 2 means 2 raised to 1, 2 raised to n plus 1. Okay, now we integrate with respect to x. Then antiderivative of 1 over 2 plus 3x dx using u substitution we get here. That's something divided by 3. This is in fact 1/3 natural log of 2 plus 3x. And in here, so I'm combining this 2 raised to 1 and 2 raised to n constant, and this integration is basically for this x factor. So sum n from 0 through infinity, -1 to the n, 3n over 2n, and outside 2n plus 1 times derivative of xn, that's n x n minus 1. Sorry, integration. This is antiderivative. Okay, so that will be x n plus 1 divided by n plus 1. Okay, and this is valid plus c, because plus c, we can write plus c in the left or plus c in the right hand side, doesn't matter. Basically we are getting one constant from left hand side and one from right hand side, because we are differentiating both sides. And but those constant we can collectively write just one in one side, doesn't matter. Let's say plus c here, and this is good for x less than 2/3. Okay, now we were supposed to find the power series just for natural log of 2 plus 3x, so 1/3. We can multiply both sides by 3. Okay, and we'll be done. But before we do that, let's find the value of c. And note that this power series is true for x less than 2/3. That means x is in between -2/3 and 2/3. So let's take any x value here. Okay, generally we can always take x equals I don't know, maybe 0. Okay, take x equals 0, we get 1/3 natural log of 2 plus 3 times 0, 2 natural log of 2, and the absolute value of 2 is 2, equals when x is 0, 0 raised to anything is 0, so the whole part is 0 plus c, just c. Okay, so c is in fact 1/3 natural log of 2. Okay, so let's go back and write this. Then we have 1/3 natural log of 2 plus 3x is equal to, I'm just replacing c by 1/3 natural log of 2, n from 0 through infinity, -1 to the n, 3n over 3n x n plus 1 over 2 raised to n plus 1 times n plus 1 plus c. c is 1/3 natural log of 2, but we need to get rid of this 1/3 to get the final answer, because we are just trying to find the power series for natural log of 2 plus 3x. So 1/3, so multiply throughout by 3, then we get 1/3 times 3 is just 1, so natural log of 2 plus 3x, okay, is equal to, when we multiply by 3, that goes on the top, so 3 times 3n, that's 3n plus 1, n from 0 through infinity of -1 to the n, 3n, and multiplying by 3, 3n plus 1 x raised to n plus 1 over, I want to write n plus 1 first, and 2 raised to n plus 1. Okay, plus if we multiply we get natural log of 2. Okay, and this is true in this interval. The interval of convergence is -2/3 to 2/3. Final.